Have you ever just looked up at the sky and really wondered, why is it blue? You know, it seems like such a simple question, but the answer? Oh, it's going to take us on this amazing journey, all the way from the sun, through the total emptiness of space, and right into a kind of cosmic light show happening in our own atmosphere. So, let's get into it and solve this great sky mystery.
Okay, so this is the real heart of the puzzle, right? Down here, on a clear day, we've got this beautiful, brilliant blue sky. But then you see pictures from astronauts in space, and it's the complete opposite, just pitch black, total darkness, even with the sun blazing away. So what's the big difference between down here and up there? Well, that's exactly what we're going to figure out.
All right, so our first clue in this whole mystery, well, it's not actually in the sky. Nope, it's in the light that's traveling from the sun. To crack this case, we've got to understand what sunlight really is. You know, sunlight is pretty sneaky. To us, it just looks white, maybe a little yellowish, but what's really going on is that it's this incredible cocktail of all the colors of the rainbow. We're talking red, orange, yellow, green, blue, and violet, the whole shebang, all squished together and zipping through space as one beam. I'm sure we've all seen this in science class, right? A prism. You shine a beam of white light into it, and boom, out comes a rainbow. Well, think about this. Something very similar is happening between the sun and your eyes. Something is acting like a giant prism, splitting that light apart, but for some reason, we end up seeing one color way more than all the others. So here's the absolute key. Out there, in the vacuum of space, there's, well, nothing. Nothing to get in the way of that light. So it just travels in a perfectly straight line, with all those colors still bundled up tight. That's why, if you're not looking right at the sun or a star, you just see black. There's nothing there to spread the light out and fill the void. Okay, so if space is totally empty, then what's so special about Earth? What do we have that space doesn't? And that brings us to clue number 2. This invisible shield wrapped all around our planet, our atmosphere. Yeah, you can think of it like a huge, invisible blanket wrapped around the Earth. And this blanket is not empty, oh no. It's packed, and I mean packed with teeny, tiny gas molecules, mostly nitrogen and oxygen. And the moment sunlight hits this blanket, everything changes. This right here is the magic word, scattering. It's the whole game. When that beam of sunlight, with its rainbow of colors, comes barreling into our atmosphere, it doesn't just get a free pass. It slams into all those little gas molecules, and the light just bounces off in every direction imaginable. It's like a cosmic game of pinball. But, and this is where it gets really cool, not all the colors play this pinball game the same way. They don't all scatter equally. There is one clear winner, one color that bounces around more than any other. And you guessed it, that color is blue. So why blue? Well, it all comes down to physics. See, blue light travels in these short, choppy, high-energy waves. Think of them like super bouncy little marbles. Red light, on the other hand, travels in long, lazy waves, more like heavy bowling balls. So what happens? Those bouncy little blue waves are the perfect size to smack into the tiny air molecules and ricochet all over the place. The big, heavy red waves, they mostly just plow straight through.
And we're not talking about a small difference here. Blue light scatters about 10 times more effectively than red light. It's not even a fair fight.
Just look at that difference. It's huge. Because those little blue waves are bouncing around like crazy, they end up filling our entire atmosphere. From our point of view down here, it looks like the entire sky is just painted blue. Okay, so let's put all the pieces together. When you're standing outside and you look up, you're not actually looking through the air to see space. No, you're looking at the air itself, which is literally glowing with all this scattered blue light that's coming at your eyes from every single direction at once. And that is why our sky is blue. But wait a minute, I know what some of you are thinking. If shorter waves scatter more, and violet has even shorter waves than blue, then why isn't the sky purple? That is an excellent question. And it turns out there are a few really interesting reasons why blue still wins the day. Okay, so here's why it's not violet. For one, the sun just doesn't put out as much violet light as it does blue light to begin with. Second, and this is a big one, our eyes are just naturally more sensitive to blue. We're built to see it better. And finally, a lot of that violet light actually gets absorbed way up high in the atmosphere, so it never even makes it down to us. Blue just hits that perfect sweet spot. All right, so let's bring this all the way back to our original mystery. Why a blue sky here, but a black sky in space? It really is this simple. It all boils down to one thing, the atmosphere.
Here on Earth, we have this thick blanket of air that scatters blue light everywhere. Out in space, it's an empty vacuum. No air means no particles, which means no scattering. The sunlight just shoots right past in a straight line, and the background stays completely black.
So here's the bottom line. The beautiful blue sky you see isn't some kind of painted ceiling up there. It's an active, dynamic light show that's happening all the time. It's what happens when the sun's full rainbow of light crashes into our atmosphere, and the blue part of that light wins the scattering game, filling our entire field of vision. It's pretty amazing when you think about it.
And that leaves us with one last really cool thing to think about. We know our sky is blue because of our air. So, what about other planets? Take Mars. It has a super thin atmosphere and it's full of this fine reddish dust. Now that you know all about how light scatters, what color do you think the sky is on Mars? It's a fun little puzzle that uses the exact same science we just talked about.